And our session title will be AI and IoT in healthcare, agriculture, and data security. On this auspicious occasion, I welcome all the research scholars who are here eagerly to present their research articles, research directions. So it will be soon evaluated by the profounded professors with us. So before getting into the session, I would like to introduce the session chairs to all the participants. So the session chair, Dr. Krishan Chandra Mishra, he is the head of ECE department in Women Institute of Technology, Dehradun, India. He is a versatile academician with more than 12 years of experience in teaching and 8 years of experience in academic program development and quality unit. He has taught diverse subjects like iOS development, Android development, cross-platform mobile application developments, and he is very much interested on software engineering based subjects like object oriented programming, operating systems, etc. He worked as a supervisor of various web development, IoT based and mobile based application projects. He has published papers, and his research scope includes search engine optimization, knowledge engineering, IoT, big data analytics, e-learning, data mining, ISO, and so on. He worked in his administrative sector, such as preparing program learning outcomes, study plan development, program specification development, course specification development, operational plan, graduate attributes, management of graduate attributes. In quality unit, he worked on evaluating the key performance indicators for a particular program and how to prepare annual program report, analyzing the course report, etc., etc. So such a dedicated educationist is here with us for reviewing your research articles. I wholeheartedly welcome the session chair over here. Thank you, sir. So when Mohammed sir joins us, at that time I will give the introduction for Mohammed Lutfi Othman, sir. So meanwhile, shall we continue the session, sir?
Yes, ma'am.
Yes. Yes, sir. Thanks a lot, sir. Yes. So participants, sir, I have shared you the evaluation sheet, sir. So now the instruction to participants is please stick on to the timing. So 10 minutes for your presentation and 8 minutes you can allocate for your presentation and 2 minutes for question and answer discussions. And your papers will be evaluated for 10 points, 4 points for your technical contribution and 2 points for your proposed methodology and 2 points for your way of presentation and 2 points for questioning answer session. So this way the papers will be evaluated, and today is the last day of our conference, and in the afternoon session valedictory will be conducted from Indian timing 3 p.m. Indian timing 2:15 to 4:15. So at that time we will be announcing the best paper award, and that best paper award will be given best paper certificate. So this is the instruction to participants. Kindly stick on to timing. I will call you upon by your paper ID order. Paper ID 16, Tinea corposis skin disease detection using CNN and kernel SVM. Miss Akshi Jain, are you here?
Yes, ma'am, I'm here.
Okay, ma'am. Thank you. And one another information from our end is all the participants are requested to stay back in the session till the end of it, so that at the end of the session we will share you the feedback form. That feedback form submission will be considered for your attendance, and that will be evaluated by our organizing team for giving you the certificates. So please be waiting in the queue in the session till the end of it. So now over to you, Akshi Jain, ma'am. Please proceed.
Yes, ma'am. Thank you. Can I share my screen?
Yes, yes, sure. Thank you.
Ma'am, I cannot share the screen while you're sharing the screen. So can you please stop sharing your screen?
Yeah, yeah, yeah. Yes. Thank you.
So, ma'am, can I ask if my screen is visible or not?
Yes, visible, ma'am, visible. Please proceed.
So, so first of all, good morning to all the authorities present here. I, Akshay Jain from Chandigarh University, with my teammates Madan Lal Saini, Aman Satnani, and Ashpi Bichu, are here to present our work that is Tinea corporis skin disease detection using CNN and kernel SVM. First of all, I would like to thank organizing committee for giving us the opportunity to present our work. Our research comprises of the following table of content that is abstract, introduction, existing system, literature survey, proposed architecture, result and discussion, future scope, and references. In this research, we have discussed about skin diseases that are on rise, affecting 1 billion people globally, ranging from acne to life-threatening skin cancer. Notably, ringworm tinea corporis is becoming more prevalent, particularly in India, where the cases have surged from 2% to 40% in certain regions. This research explores innovative image acquisition methods, datasets, deep learning architectures, and frameworks for diagnosing skin conditions. A novel machine learning based techniques using convolutional neural network is presented for ringworm identification, but rigorous testing crucial to ensure its effectiveness and safety. The study also applies a linear kernel support vector machine for parametric datasets, enabling valuable result comparisons. Ringworm is a common fungal infection affecting the skin, scalp, and nails, poses a significant health concern due to its ease of transmission via contact with infected individuals, animals, or contaminated objects. This ailment is caused by a group of fungi known as dermatophytes and often eludes easy identification, as its symptoms can mimic those of various other skin disorders. However, the emergence of deep learning, a subset of machine learning, holds a promise of revolutionizing ringworm detection. By training neural networks to recognize distinctive patterns in images of the affected skin, deep learning can enhance accuracy and efficiency of diagnosis, gradually improving as more data is added to its training dataset. This advancement in medical technology offers a precise and effective means of recognizing and treating this prevalent fungal condition. This study, the skin disease diagnosis using CNN with SVM techniques, suggests a convolutional neural network and supports vector machine based skin disease diagnosis system. In the suggested system, a CNN is trained to identify characteristics from pictures of skin lesions. These features are then fed into an SVM classifier to be classified. The SVM model is trained using the features that were taken out of the CNN and after the model has been trained on a sizable dataset of skin lesion photos. Another research study, fungal skin disease classification using the convolutional neural network, is to use CNN to categorize the most prevalent fungal skin diseases such as Tinea corporis. A study by Sachin Sharma used models such as simple Bayesian, random decision trees, SVM with kernels, and convolutional neural network, and logistic regression. Among all the selected methods, CNN provides the highest training precision for correct expectations of skin disease. A study by Naval Soliman resized the images and extracted the feature trained convolutional neural network. Using the multiclass SVM features, then classified after that. The individual was shown the findings, revealing the ailment natures. Another author concerned on the feature extraction using advanced techniques like CNN, classifying the pictures using softmax algorithm, reduced the diagnosis result as a result. Vinay Shekhar Kumar focuses on the model based on the maximum entropy model and ANN to identify the disease. Samit Bakshi used a pre-trained CNN and VGG16 model on the dataset of 12,000 images and achieved an accuracy of 88%. In our research, we proposed a CNN model that would be trained on a large dataset for ringworm images to extract key features. The first layer contains of 512 neurons with 32 filters having a learning rate of 0.001. The second layer contains 256 neurons, that is exactly the half of the neurons in the first layer, with the max pooling size of 2 cross 2. Output layer contains two neurons, each for healthy and affected skin. Extracted features would serve as an input for the SVM classifier to categorize the images. Advantages include faster diagnosis, reduced cost, and improved patient outcomes. In our research, we developed a model to predict ringworm disease using image and clinical feature datasets. It utilized publicly available data for the study. We have explored machine learning models including random forest, multiple linear regression, decision tree, and SVM, with SVM achieving the highest accuracy of 83.53%. We have used a linear kernel SVM for the clinical feature dataset, achieving a specificity of 75% and sensitivity of 86.89%. We have implemented a convolutional neural network for image dataset, specifically Ismail Hussain and Ham with dataset achieving an accuracy of 91%. Combined results from clinical features and CNN models for effective tinea corporis disease identification compared with the result of previous research by Parvat Neni, who achieved an accuracy of 85% using CNN. With our research in the coming future, with the help of deep learning methods and algorithms like CNN, this study will focus on ringworm identification and will also be able to gauge the severity of the infection and will advise the patient on what to take as medicine for the cure based on the severity and intensity of disease. In order to diagnose the ailment as comfortably as possible for the patient, this software will accept both parametric and graphical data as input and will use a high resolution images for better efficiency. These are the references and the link to the dataset that we have used in a research paper. And at last, I would like to thank you all for giving me the precious and your valuable time.
Oxygen.
Yes, sir.
Ah, yes. The model is the best and usable if implemented in the medical field. You have collaborated this thought, yeah, share this thought to any medical organization?
Yes, sir.
Yes,
Actually,
sir.
my own
Actually,
brother
my own
is
brother.
pursuing MBBS, and I have actually considered it with him that is there any proposed model or something like that for available for tinea corporis? Actually, ringworm has many types like tinea
No, no,
corporis
no.
and all the other things.
My question is, we are planning to implement anything with related to any field, like a medical field, might like a agriculture field, like any other field. So we firstly sign a MOU with any other organization and practically implemented. You have done this process to practically or only through the image?
No, so actually we have also conducted it practically with SVM. Like for we have taken the parametric data set containing like 150 entries, and for that, for comparison and all purpose, we have used the SVM classifier. And for the image data set, currently we are pursuing for the implementation, and in the future we will use some high resolution images for that.
Okay, through you have done through the image processing. Okay,
Yeah, and SVM classifier for the comparison basis.
okay. Okay. Now, thank you.
Thank you, sir.
Thank you, sir. Thank you. And next participant is 109, paper ID 109, Miss Amanpreet Kaur,
Yes,
enriching learning and streamlining efficiency. Yes, please proceed, ma'am. Yes,
Yes,
your
ma'am.
voice is audible. You can please proceed.
Okay, thank you, ma'am.
1 minute, I will stop. Yeah. So all the participants are requested to stream your video also while presentation.
Okay, ma'am.
Yes, ma'am. Thank you.
Can I start, ma'am?
Yes, yes, you can please.
Yes.
Please, please.
First of all, good morning to everyone. Thank you for giving me this opportunity to present myself in this third international conference on technology advancement in computational sciences. My topic for the research is enriching learning and streamlining efficiency, how cloud IoT is advancing education, basically. My paper ID is 109 and my name is Amanpreet Kaur. I am the first author of this paper. So first of all, I would like to start with the contents of my research papers. I will discuss abstract, introduction, after that research methodologies, proposed work, discussions and future works, conclusion, and last, I have included all the references used in this paper. So that's first, this abstract of my paper explores the integration of cloud IoT within the educational domain and the remarkable effects it has on teaching, learning, and administrative procedures. The optimization of resource allocation and campus security are other benefits of cloud IoT. And this fusion of cloud IoT and cloud computing or Internet of Things has initiated significant changes across various industries, that is also including education as well. So in this paper actually examines the nature of cloud IoT by increasing the student participations, maximizing resource management, and encouraging individualized learning opportunities. First, I will discuss first factor, that is enhanced student engagement, how student engage how we can enhance the student engagement with the help of this cloud IoT. Actually, students are encouraged to interact and participate in active learning with the help of smart IoT enabled gadgets like interactive whiteboards, smart projectors, and wearables. Cloud-based environment gives access to vast array of educational fields, including multimedia content, virtual simulations, and online courses. Students can engage in self-paced learning, reinforce their understanding of complex concepts. Governments and organizations are using IoT to improve processes, leverage data, and increase efficiency. Some universities make extensive use of smart devices and technology, and we are using also. And second point, I will discuss the optimized resource management. Institutions of higher education face numerous obstacles in administering their resources efficiently. Cloud IoT solutions address these obstacles by providing real-time data monitoring and analytics. IoT examine energy consumption, heat, and temperature in school infrastructure, which allows the organization to evaluate areas for improvement and implement power-saving measures. Personalized learning experience is the other factor. By utilizing IoT devices and cloud-based systems, information on students' learning behaviors, advancements, and preferences is gathered. Adaptive learning applications supported by cloud IoT use real-time data on students' performance to tailor educational content and delivery to their individual abilities. So a last point, remote learning and accessibility. With the help of cloud IoT, which played a vital role in advancing remote learning and making education accessible to students worldwide, during unforeseen events such as COVID-19 pandemic, cloud-based platform enables seamless transitions to virtual classrooms, ensuring continuity in education. IoT devices like connected tablets, laptops, and smart educational tools facilitate remote learning by enabling teachers to interact with students in real time, conduct virtual lecture, and provide immediate feedback. Cloud storage and collaboration tools allow students to access educational materials and collaborate on projects regardless of their physical location. To achieve this research methodology, I have used mixed method research approach that will be included literature review, surveys and questionnaires, case studies, and data analysis. First, I will discuss about the few papers which I have considered in this literature review. The first paper which discussed how cloud IoT technology enrich the learning experience of students and educators. It discusses personalized learning pathway, real-time feedback mechanism, interactive learning tools, and gamified educational content as demonstrated in the paper by Jin. The improvement of learning experience is a crucial component. Real-time access to customized learning material and interactive tool is made possible by cloud IoT. The Internet of Things and serverless computing are two technology innovation that could significantly affect the field of education, and this is the main concern. Next, serverless computing is a cloud computing architecture enables developers to focus on coding while the cloud provider take care of infrastructure management and resource allocation in an automated manner as required. Second, for a second method I have used for research methodology that is on the basis of surveys and questionnaires, administrators surveys and questionnaires to educators, students, and administrators to gather qualitative and quantitative data on their experience with cloud IoT implementation in educational setting. Third method I have used in this methodology is case studies. We have conducted various case studies in educational institutes that have adopted cloud IoT solution analyzing the outcomes, challenges faced, and lessons learned. Last step I have taken for the research methodology is data analysis. Analyze the collected data using the appropriate statistical method and qualitative analysis technique to draw meaningful conclusions. So in the proposed work, we introduce the relevant academic study on the concept of smart learning environment in this part. This study aims to demonstrate how merging instructional strategies from relevant fields may enhance the learning process. This research advances due to the fusion of IoT technology with educational teaching methods, leading to the proposal of two innovative learning approaches. I have used two innovative learning approaches for the same. The configuration of the Internet of Things based smart learning process. This approach uses IoT devices and sensors to enable personalized learning experience, interactive and immersive educational content, real-world application, instant feedback, collaborative learning opportunities, improved teacher support, data-driven insight, and increased accessibility for all the learners. Combining IoT teaching methodologies improves learning by making it more dynamic, adaptable, and efficient. Second approach is the IoT learning approach through the use of IoT devices and sensors. This approach seeks to create a dynamic and interactive learning environment that adapts to the specific needs of students. So three important issues will be covered in the research in the teaching or IoT field. First is confidentiality, ensuring the security and privacy of student information and data gathered by IoT devices to secure sensitive data from unauthorized access. It is essential to put in place strong data protection procedures. Data accessibility, ensuring that teachers and educators have easy access to the data gathered by IoT devices. Real-time monitoring and analysis will be supported by reliable data availability, enabling prompt action and individualized learning opportunity. Pedagogical techniques in education, examining and implementing effective IoT-based educational strategies, knowing how to effectively use IoT device to enhance teaching strategies, promote interactive learning, and fulfill the diverse learning needs of students is required for this. So this is my few discussion about this proposed work. I have examined 4 factors for the types of learning we have conducted: online learning, traditional learning, personalized learning, blended learning, and project-based learning. On the feedback of the 3 online learning, it is tailored education experience to meet individual student needs, interesting and learning style, and its effectiveness from the other factor is number 5. And traditional learning, which emphasizes teamwork and communication with students working together in a group. Personalized learning describes, encourages hands-on experience to facilitate active learning and deeper understanding. Blended learning integrate educational content into game to make the learning process engaging and enjoyable. Project-based learning combines traditional classroom instruction with online teaching components. Basically, what we have concluded from these type of learning is online learning is flexible approach that leverages digital resources and cloud IoT platform to provide education. It can be personalized to suit individual student needs, making it highly effective. So therefore, rating of 5 would be more appropriate to reflect its effectiveness. As you can also see in this graph, so online learning have the high rating that is 5. Traditional learning basically involve face-to-face classroom instructions and often emphasize teamwork and communication. While it can be effective, especially for certain subjects and interaction, it may not be as adaptable to individual needs as online learning. A rating of 3 would be more suitable. Learning tailor education to individual students, but may not necessarily encourage hands-on experience exclusively. It aims to meet students' needs, which can be quite effective. A rating of 4 would better reflect its effectiveness. Blended learning combines both in-person and online components, providing a balanced approach to education. The integration of educational content into games can make learning more engaging and enjoyable. A rating of 3 would be a fair assessment for its effectiveness. Project-based learning emphasize hands-on real-world project. It is an effective way to promote active learning and deeper understanding, making a rate of 4 more appropriate. Well, conclusion for this, the cloud IoT has revolutionized and the educational sector and fundamentally altered how people learn. This powerful combination of cloud-based technologies and IoT devices has opened the door to more dynamic, straightforward, and personalized learning environment. School may now offer tailored learning opportunities, better manage their resources, and boost student engagement by utilizing cloud IoT in order to prepare students for success in a connected and data-driven world. Cloud IoT is likely to have a stronger impact on education as technology advances. These are the references I've used in this paper. And thank you so much for giving me this opportunity to present myself in this conference.
Thank you, Ms. Amanpreet. Now, from the organizing committee, it's my duty to welcome Dr. Mohammad Lutfi Othman sir for the session. So he joined us right now. So as a customary practice, I invite you to this event, grand event, wholeheartedly, sir. So now I will share my screen before asking question session. Amanpreet, please kindly wait for a few minutes. I will finish off the procedure.
Right, ma'am.
So 1 minute, yeah. I will stop your screen sharing
Right, ma'am.
for 2 minutes. So I wholeheartedly welcome Dr. Mohammad Lutfi Othman sir, Associate Professor, University Putra, Malaysia. So telling more about sir is a senior member of IEEE. He received his BSc degree, magna cum laude distinction award in electrical engineering from the University of Arizona, USA in the year 1990, and he has done his MSc and PhD degrees in the electrical power engineering field from University Putra, Malaysia in the year 2004-2011 respectively. He is currently working as an associate professor with the Department of Electrical and Electronics Engineering, Faculty of Engineering, UPM, where he is also the research member of Advanced Lightning, Power and Energy Research called ALPER. He also practices as an electrical engineering consultant in electrical services installation works by diversifying as the electrical director partner in a local engineering consulting firm. He is also a professional engineer with practicing certification under Board of Engineers Malaysia, BEM, a chartered engineer under Engineering Council UK, a professional technologist under Malaysian Board of Technologists a registered electrical energy manager under Energy Commission Malaysia. He is a certified professional in measurement and verification under Malaysian Green Technology Corporation. His research areas includes power system protection, protective relay operation, modeling and analysis, computational intelligence based data mining for knowledge discovery in relay database, application of artificial intelligence in protection algorithms, adaptive numerical protective relays, development of numerical protective relays, power system operation, where he is involving with power quality management, smart grid management, distributed generation of power, electrical service installation works, which includes design and project administration consultancy, and energy efficiency management, which includes demand side management, energy efficiency management, and building energy management systems. Such a proficient academician is with us today. So we thank you sincerely for your wholehearted presentation to enhance this session, sir. Your presence makes valuable thing for all of us. Thanks a lot for being with us today, sir.
Thank you.
So now, yes, sir. Yes, sir. Now we can proceed with the question answer session for Miss Amanpreet. Meanwhile, I request Dr. Krishan sir to enable your video, sir, so that I can take a formal photograph.
Yeah, sure.
Lord, sir, thanks a lot. Yeah.
No issue.
Yes, sir.
Amandeep Kaur, are you here?
Yes, sir, Amanpreet here.
Yeah, Amanpreet. How do you done your case study of this research paper?
Sir, actually, I have learned various case studies from the various research paper I have considered for the references. So on that paper, on the basis of that paper, I have done questionnaires with my and I have made questionnaires and shared to the students and faculty. From that, I have taken that feedbacks, and according to that, I have made that draft. I have
Okay,
various.
you have collected this feedback through the physical visited or through the Google form and any other way?
By Google form, by sharing Google form and all this.
Okay. So how can you justify the authentication of this data?
So because they are using IoT devices very well, they are more efficient to use IoT devices. They have more knowledge about these IoT devices. In this era, we are using IoT devices. We are dependent on IoT devices. On the basis of that, online learning is the best opportunity for the students and the educators as well. So I just want
Okay,
to.
one word you
Yes.
no issue. You use one word, tailor educational experience.
Yes.
Can you elaborate? Yeah, explain.
For what educational experience?
Tailor educational experiences. You use this word in this PPT.
Sir, actually, educational experience from the past era, like we have first traditional learning, then we have done in the traditional learning, we have just face-to-face conversation, not IoT devices, not even a single device which is basically on the sensors and all these things, not mobile phones, not we have using a keyboard and all these things, and all IoT devices. Without IoT devices, we have learned various things from our educators, and after that, with the increasing in advancement of the technology and this technical era, we have learned so many things that from, and we have converted from traditional learning process to the online learning process. And most of the time we have learned in COVID-19, where we have used maximum IoT devices to learn or to enhance our knowledge.
Okay, thank you.
Thank you, sir. Thank you so much. Thank you, ma'am.
Thank you.
And good morning, Mohammed Sufi sir. Namaskar.
Yes, here afternoon. Good afternoon. Good morning over there. Thank you for having me in this program. Thank you very much. I really appreciate it.
Yeah. Okay, thank you, sir.
So any questions to Amanpreet, sir?
Yes, just sorry I came late, but what I can gather from the presentation. I just want to know how this IoT-based learning can be very much actually useful in this age of today's most basically the learning process has gone through a lot of changes, especially on online teaching. So how is it IoT-based learning is such of great use?
Sir, actually, I would like to explain this with the help of my example. For example, I have studied before 10 years. I have passed out 2014. So at that time, these devices are not available. Right now, these IoT devices are so useful and giving so much opportunities to learn with the help of these IoT devices as compared to traditional learning. There are no such learning at that time. At our time, even we don't have access to internet and YouTube and all these things and all IoT devices. Now in this era, students have more opportunity to learn through these cloud IoT devices uh, uh, without any expense, you can say. It's almost free. Any
Mm.
software we can use, free software, we can use internet facilities, we can use sensors. With the help of sensors, we can use different technologies. Okay, we can do more research on this field. I would like to research more on this topic because I am very interested in this topic, and I am also searching on these devices. Even I'm like in AIML, we are using IoT devices very much efficiently, and we
Mm.
can predict each and every output from the experiments. We can predict weathers, we can predict uh, any type of circumstances with the help of algorithms and with the help of these IoT devices. You need not to go anywhere to learn these things. All the devices, all the IoT devices, you can learn from your sitting only. You need not to go anywhere. So online learning is the best. My conclusion for this paper is online learning is best for educators as well as students.
Thank you very much.
Thank you, sir. Thank you, ma'am.
So next to Ms. Aman Preet is paper ID 110. Ms. Sami Samita, are you here? Ms. Shamita? Okay. So Mr. Gurdeep Singh, paper ID 177, mango leaf disease severity scale classification.
Yes, ma'am. Yes, ma'am. I'm available. Yeah.
Yes, sir. Yes, sir. Please proceed, sir. Paper ID 177.
Yes, ma'am. Yeah.
Yes, sir.
Let me share my screen. Are you able to see my screen?
Yes, sir. It's loading. Ah, visible, visible. Please proceed.
Okay. Okay. Hello, everyone. I'm excited to have you all here for our online presentation. I want to express my gratitude towards MIT University for this chance. Let's not waste any time and jump into the presentation. So today I'm going to present on the topic mango leaf disease severity scale classification using REST Next 50 model, a deep learning based approach. My name is Gurdeep Singh, and I'm a MEA student and at Chandigarh University, and my co-author name is Dipshika Chabra. So I'm going to present given content today. So abstract mango production faces challenges from leaf diseases impacting both yield and tree health. Mango leaf sooty mold disease, known for its adverse effects on photosynthesis and tree vigor, is a major concern. The research explores RES Next 50, a deep learning model for severity classification of mango leaves sooty mold disease. A dataset of 25,000 photos from various mango fields enables automated severity assessment. The ResNext 50 model achieves an accuracy of 94.61% and provides insight through parameter analysis, performance metrics, and confusion matrices. Comparison highlights the model competitive advantage. This study showcase the potential of deep learning for disease management in agriculture, offering prospects for automated mango leaf disease evaluation. The mango plays a significant role in agriculture and the economy. Disease pose obstacles to sustainable mango production, with mango leaves sooty mold disease having a substantial impact on plant health and productivity. This disease is primarily caused by dark pigment fungi from the genera Capodium and Limasunella, forming soot-like coating on plant surfaces. The disease negatively affects photosynthesis and growth by blocking sunlight penetration into the canopy. Sooty mold infestations also attract additional pests and insects, compounding mango orchard challenges. Accurate and timely disease severity assessment is crucial for protecting mango crops. Traditional manual inspection methods are subjective and intensive. Cutting edge deep learning methods combined with imaging datasets enables automated disease categorization and severity estimation. The research employs the RES Next 50 deep learning model to categorize mango leaf sooty mold disease. A comprehensive dataset with 25,000 images from multiple mango fields showcasing various disease severity levels has been created. The dataset classified different diseases severity levels, aiming to develop disease management strategies and offer actionable insights to protect mango crops using deep learning. Existing system, traditional inspection, manual grading system, machine learning based approaches, transfer learning, data augmentation and image processing, multimodal approaches. Reduce survey. Mango disease cause yield and income reduction. Crop condition significantly impacts agriculture output. Introduce a low cost disease classification method using a CNN, CCA fusion extracts and combines features. An ultrasonic sensor detects bacterial canker and blight. Signals from probing mango leaves establish disease detection criteria. The strategy improves mango crop management with 90% accuracy. Proposed architecture. Choice of RES Next 50 deep learning architecture. In this investigation, the RES Next 50 deep learning architecture was selected as a fundamental model. Feature extraction capability. RES Next 50, an evolution of ResNet architecture, demonstrate a remarkable ability to extract nuanced features from images, a critical factor in disease severity classification. Utilization of pre-trained weights. The model was configured with its pre-trained weights, leveraging the knowledge acquired from large-scale dataset unrelated to mango leaf sooty mold. Modification of fully linked layers. To ensure capabilities with the classification task, the final fully linked layers were adapted to match the number of serenity classes, maintaining the architectural consistency. Model architecture. The architectural layout of proposed model is illustrated in given figure 1. So here is the input as an image, and we have a 7 into 7 kernel size, and then we are making a 3 by 3 size, and it will pass from the four filters having a like 64 filters, four levels which contains the 64 filters, 128 filters and 256 filters and 512 filters, and depending upon that it will going to create a matrices on resulting scale 1, scale 2, scale 3, scale 4 and scale 5. Result and discussion. Performance of REST Next 50 DL model. The REST Next DL model displayed exceptional performance in accurately categorizing the severity of mango leaf sooty mold disease. Comprehensive accuracy. The model achieved an impressive accuracy rate of 94.61%, indicating its proficiency in categorizing various disease severity levels with precision. Model architecture analysis. To delve into the intrinsic of a model's architecture, the study provides a layer by layer distribution of parameter as outlined in a table 1. Analysis of architecture, depth and complexity. Table 1 present an analysis of depth and complexity of the RES Next 50 architecture, highlighting the progressive increase in parameter as the network advances through its layers. Result and discussion. Model performs evaluation. Table 2 complies essentially performance matrices, including precision recall and F measures for each severity scale, providing a through assessment of model's ability to distinguish various disease manifestation level. In table 2, we have a scale 1, scale 2, scale 3, scale 4, scale 5, depending upon the precision recall and F1 measure percentage. Confusion matrix visualizes classification result for each serenity class with diagonal elements representing correct classification and off diagonal elements indicating misclassification. Overall performance offers a concise overview of model performance across all classes. Analysis: an intermodal comparison and an intra-model comparison will be performed as the investigation progresses. These they will be treated as separate but complementary viewpoints. Competitive evaluation: the suggested RES next 50 based models competitive standing in plant disease categorization is evaluated by comparing it to state of art method. Performance comparison: figure 3 illustrate that RES next 50 based models accuracy is on par with or superior to other method, supporting its effectiveness in determining the severity of mango leaf sooty mold disease. Intra-model comparison. In addition, the model's ability to differentiate between various varying scales of disease manifestation can be ascertained by analyzing its performance under a variety of severity classification. Figure 4. Intra-model comparison graph highlights the model's capacity to attain high precision and recall even for the more difficult severity levels, further establishing its promise for accurate disease evaluation. Here is the graph representation promising of RES Next 50 model. The study highlights that the RES Next 50 model uh, potentially for categorizing mango leaf sooty mold disease severity. Comprehensive evaluation, layer-wise parameter, performance matrices, confusion matrices, and inter and intra-model comparison provide a throughout evaluation of a model performance. Future enhancement objective. Research aims to use DL for categorizing mango leaf sooty mold disease severity in mango architecture. Accuracy. REST Next 50 model achieved an impressive 94.61 percentage overall accuracy in categorizing illness manifestation levels. Capability demonstration. Layer-wise parameter analysis, performance matrices, and confusion matrices confirm the model's capability or the agricultural task. Future direction. DL application in agriculture disease management hold great potential with possibilities such as model refinement for specific disease characteristics and domain knowledge incorporation. Generalization improvement, expanding the dataset to encompass a wider range of disease presentations, geographical areas, and environmental factor would enhance model generalization. Real-time monitoring with sensors and drones. Real-time disease monitoring through sensors and drone is explored. Explained AI algorithm. The adaptation of explained AI algorithm is considered for providing insights into a disease evaluation. Collaboration for innovation solution. Collaboration between researcher and agriculture specialists and technology developers could lead to innovative disease control solution. Sustainable mango cultivation. These efforts aim to enhance sustainable mango cultivation capacity. Here is the references which I took for writing the papers, and thank you.
Thank you, Gurdeep Singh, for
Thanks.
the presentation. I think you used the RES Next 50 model in this
Yes, yes,
whole the
yes.
presentation. Any other model will also be available for this process?
Yeah, sir. There is a CNN model is also available for that, for the plant disease detection, and also I write a one review paper on that as well. By reading those papers, depending upon that, I choose a mango and write a paper on that one.
Okay. Which method is best? RES Next or CNN?
Both have their own pros and cons, but in my point of view, I go with RES Next 50. But
Okay.
I can also see accuracy, also CNN model has also achieved the same accuracy level, which we are able to achieve by RES Next 50 as well.
Okay. Okay. Thank you. Thank you.
Yeah.
Right. Okay, all right. Mr. Guri Singh, yeah? So I've seen your RES Next 50. What does that RES Next 50 really mean? I mean
Sorry, sorry.
the full name of RES Next 50.
The full name of RES Next 50.
Yeah,
So this is so you are asking about the model full name?
yeah, yes,
Okay.
yes.
So it's a residual network with 50 layers, 50 weight layers, something like that.
Oh, residual network. Okay, right. Okay, when I see your results, you were comparing a number of techniques that your work against all the other works that other people have done, and I've seen you are comparing the same technique that you are proposing, the RESNext 50, one of the slides. Yours is 90 something, and the same name, which is RESNext 50 also, is actually 84. So how is
So,
this?
sorry, can you please rephrase your question? I didn't get it.
I've seen your one of your slides. You were comparing your proposed RESNext 50 and also with rather similar RESNext 50 also actually. So I'm a little confused.
No, like
Maybe
I just took a references from there, and that's like right now, like I'm on new on this, like on researching on that, and maybe in the upcoming year I'm going to evaluate like more implement a different kind of architecture as well. So right now I just took a references and implement a similar kind of architecture. Yeah.
what I'm seeing is that you're comparing the same technique that you are using. So I'm just asking what's the
So
improvement that
you
you have introduced in your work, because in your technique you're calling it improved RESNext 50, and you are comparing with RENext 50
No,
as well.
I'm
So
comparing with us like CNN models, like for the with the
is
plant
it
distance. Yeah,
okay? It's okay, but it's shown in one of your slides as such actually.
might be there is an incorrect data.
Okay,
Let
all
me.
right.
I'll
Okay.
check it.
Yeah.
Like,
Okay. Sorry. Just one last question. You have mentioned in the next future work, how is this mango, this disease can be of a great use in future cultivation? In what sense is that?
so how it will be great in a future cultivation, like how it will be useful for like entire world, right? You are asking that, right?
Yes. 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 Yes.
Yeah. So like there is a multiple use. Like if we like use this model, right, then we are able to like it will be helpful on a global like the production as well, right? It will provide us it will provide an economic impact as well. Agriculture's sustainability is also there, right? And yeah, that's it.
All right. Thank you very much.
Thank you. Yeah.
Thank you, Mr. Gurdeep Singh. Now, next participant is paper ID 207. Malware analysis using machine learning and deep learning. Participant, are you here?
Yes, ma'am.
Yes, ma'am.
Yes, please proceed. Proceed, ma'am. Thank you.
Just give me a second, ma'am. I'm sharing my PPT.
Sure, sure, sure. Now, all the participants are requested to keep your timing 8 minutes per presentation. Okay. Thank you. Screen is visible. Yeah.
Good morning, ladies and gentlemen. My name is Riddhi Gupta, and I'm delighted to be here at this conference to share my research paper today. I want to express my gratitude to the organization for this opportunity to contribute to this vibrant discussion. My research paper topic is malware analysis using machine learning and deep learning. Malware is a significant threat to individuals and companies. Research in this area is vital, and manual analysis of malware is time consuming, and we're not fully like prepared for the 0-day attacks. And so therefore machine learning is helping to detect and analyze malware. Using better data set can lead to improved algorithms and more effective antivirus software. And so research on analyzing Android malware is growing. So ultimate goal is to develop the best method for analyzing a wide range of malware types. Yeah. Malware puts personal and national security at risk by targeting important information. India is ranked 8th globally for facing many cyber threats, detecting 2.2 million viruses. Monthly malware attacks are increasing, challenging traditional antivirus softwares, and machine learning helps analyze malware and create effective algorithm. AI learning methods improve automated detections. Malware includes viruses, trojans, worms, spyware, ransomware, and bots. Analysis uses static, dynamic, and hybrid approaches to understand and classify threats. Malicious, malicious software is hidden in pirated Android apps and endangering user data and security. Now, Astha will explain the existing system.
Hello, everyone, and good morning to one and all present here. I'm Asta Gupta, the author of the paper Malware Analysis Using Machine Learning and Deep Learning. Talking about the existing system explores the critical issue of malware analysis using machine learning and deep learning. It acknowledges the increasing threat of malware to individuals and organizations and highlights the challenges of manual analysis and zero-day attacks. The paper examines current machine learning methods and emphasizes the importance of dataset quality in algorithm development. It also recognizes the growth significance of Android malware analysis and aims to identify the most effective approach for generic datasets. The ultimate goal is to surpass previous test results and enhance malware antivirus software. Now, Riddhi will continue after this. Thank you.
Thank you, Asta. Literature survey. Literature review explores various aspects of malware analysis, including static, dynamic, hybrid, and Android malware analysis. Static analysis using labeled malware samples and machine learning achieved high accuracy in some cases. Dynamic analysis, which identifies malware based on system calls and saw good results with support vector machines and random forest. Hybrid analysis combines static and dynamic approach to test algorithm. Android malware analysis utilize different data sets and machine learning techniques, achieving around 85% accuracy. Integrated analysis combine traditional methods, classification algorithms, and deep learning to detect malware effectively. Proposed architecture. First is the raw data. This is the initial and unprocessed information or data collected from various sources. Secondly, sources in the context of malware analysis, it could be a collection of files or software samples, both malicious. Second is the pre-processing part. Raw data often needs cleaning and formatting to make it suitable for analysis. Third is the feature extraction. In this step, relevant characteristics or features are extracted from the pre-processed data. Fourth one, feature comparison. This step helps in distinguish between normal and malicious data. Fifth, training data and testing data. The data set is divided into two parts. The training data is used to teach a classification algorithm to recognize patterns, while the testing data is used to evaluate the algorithm performance. Sixth, classification algorithm. Machine learning or deep learning algorithms are applied to the training data to build a model that can classify data as other. The last one, seventh, detection result. The classification of algorithm is then used to analyze the testing data. Now Anusha will continue.
Good afternoon, everyone. My name is Anusha Kumuru, and I am also an author for the paper. And so let's talk about the results and discussion. So the decision tree is a robust classifier in supervised learning, providing good accuracy ranging from 60% to 99% on balanced data sets with equal malware and benign files. However, when accuracy exceeds 99%, it indicates overfitting. To address this, post-pruning with the cost complexity pruning was used, resulting in maximum accuracy of 99.99% with a 0.5 test size. For the future work involves creating a comprehensive dataset by combining static and dynamic malware features. The aim is to develop a custom artificial intelligence model for robust malware detection. Additionally, the potential use for the various deep learning models will be explored to enhance the accuracy in the detection process. So these are the references that we've used for our paper. Thank you so much for providing us this opportunity. We really appreciate it. Thank you.
Okay, thank you. My question is, malware is a virus or something different to the virus?
So basically, malware is a program for harming or seeking partial control over any system. So basically, it is any threat over that can be harmful for any system.
Okay, and you have mentioned two techniques, J48 and KNN techniques. Can you explain?
So KNN stands for K nearest neighbor, and it is a supervised learning model, and it is a non-parametric model. Thank you.
Okay. Okay, thank
And
you.
the second one, I'm sorry, I didn't catch the name. You asked one more. Which one did you ask?
Sorry?
KNN and you asked for two
Yeah,
models.
yeah.
Which I'm sorry, I'm not able to get the name. I think
J48 and KNN.
okay. So yeah, these are all classification models, and yeah, it's
Okay.
yeah.
Any questions from Dr. Mohammed, sir? Sir, you are not audible, sir. Your mic is
Sorry,
muted, I guess.
sorry
Yes.
about that. So, okay, apparently we have seen that you presented your proposed work, and we don't quite see the results, you know, the techniques. You have mentioned the techniques, but we don't see the results of the techniques. So, are you now still in the process of, you know, introducing some of these techniques and start working on them, or I suppose you are at the very beginning stage, I suppose, right?
So, we have worked upon this using the various algorithms. We've tested that on data sets and we provided that on the various tables, like table number 4, 5, 6, 7, and 8. So these 4 tables, they show the data on, and it's defined in the paper, and it shows the results and the accuracy along with the F1 precision. And this can be seen on the papers.
Okay. I don't quite see the table. Maybe I missed the the page. Okay. So, okay, you mentioned about this training, test rather, test the data. What strategy do you use to test the data?
Sorry, you broke, your voice broke. Could you please
Yes, you mentioned that you have used, you know, the flow chart. There's a test of data that has been mentioned in one of the boxes. So what sort of data testing strategy you guys have used in your work?
So we have used decision trees for testing data, and so basically we first train our decision tree based on the training set, and then
Okay.
prune it, and based on the accuracy that we achieve, the best accuracy that we can achieve, we are testing the data to get the final accuracy.
Okay, decision tree is a technique. What I mean is like when you are testing data, you are using such a strategy like cross validation, tenfold cross validation, things like that. You know, that's the kind of test that I'm actually expecting.
Okay, so we have so basically we have used CCP approach for this to be
Okay.
precise. Yeah.
All right. All right. Thank you very much.
Thank you so much.
Thank you, sir,
Thank
for
you.
giving us
Thank
this
you.
opportunity.
Thank you all. Thank you.
Thank you.
Thank you.
Thank you.
So next participant is paper ID 280, Dr. Abhijit. The title is Examining the Drying Procedures of Squash and Comparing Experimental Data with Existing Models. Sir, over to you.
Can I start, ma'am?
Yes, sir. Yes, sir. Please.
So good morning. We are from Tashkent, so it's still morning here. So good morning, Professor Mishra, Professor Mohammed, and Dr. Gayatri. So my name is Abhijit Taravade. I'm working as a professor at INA University, Tashkent, and we have a co-author with us, Dr. Shaknoza, Dr. Jasur, Dr. Doston, Dr. Ali. They are from the Tashkent State Technical University. So my topic for the presentation is examine the, just 1 minute, sir. Examine the drying procedures for the squash and comparing the experimental data with the existing model. So this is the content of my presentation: introduction, motivation, methodology, result discussion, and I'm just comparing with the result with the different drying models, and I'm just going to explain to you what are the future enhancement. So actually, in this research, we are investigating squash drying using SHS 8001 SPU model. It's a drying cabinet, and our aim to find the optimal drying condition under the three different temperatures: 55, 65, and 75 degrees centigrade. And we are going to squash slice. The thickness is 3 mm, 4 mm, and 5 mm. And our findings align well with the existing drying model, validating their suitability for simulating the squash drying behavior. The squash is a type of gourd. In India, we call it as a lauki. It's a rich carotenoid, pectin, vitamins, and health benefit compound. Normally, we dry these kinds of object because we wanted to extend the shelf life, because this particular objects contain high water content. So we can reduce the water content, and because of that, we can able to prevent microbial growth. So we can preserve the product. And this drying involve like different factors like the drying surface area, the temperature, air velocity, humidity, the pressure, the vacuum, and the time. The drying rate is high initially, and as the drying time will, after some time, the drying rate is decreasing over time. This analysis aims to find the optimal drying condition for the squash without losing its valuable substances and the minerals. The food preservation is critical for the food industry security, the waste reduction, and economic sustainability. Drying is a traditional method to extend the shelf life for the perishable food like a squash. Optimizing drying condition in an industrial setting can be enhanced product quality, enhance efficiency, and cost saving. The theoretical drying models often lack imperial support, and important factors like temperatures, slice thickness, drying time as under study for the squash. Our research fills the gap by providing the experimental proven insight into the ideal squash drying conditions. We will assess the existing theoretical model by comparing them with our result. This study can advance food science and technology, offering the foundation for the future research on economic implication and application to other agriculture produce and drying technology. While selecting this the squash, we normally apply some criteria while selecting when we buy this squash from the market. Yellow and dark orange thin skin we purchase from the market. Normally we peeled the squash, rinse, and we cut into the three different thicknesses: 3 mm, 4 mm, and 5 mm. In our Tashkent State Technical University laboratory, we have a unit that is universal conventional dryer. It is actually the Russian device. It is normally known as a cabinet dryer, and with the different thickness like a 3 mm, 4 mm, 5 mm, and under the different temperatures, 55 degrees, 65 degree, and 75 degree, we collected the data. I know while we collecting the data, we keep some time interval, like after 15 minutes, we check the weight of the drying object, and we recorded that all, and based on that we have analyzed our study. We, while drying any object, there are two parameters are very, very important. That is the moisture content. So we have this for the mathematical equation, that is we calculate in terms of percentage, and drying rate. Drying rate means what? Mass of water evaporated per unit time. So we have mathematical equation for that. So we collected the data, and we we calculate. We use to study this all. We use the tool like a MATLAB. Okay. So as I told you that we have dry in a three different temperature: 55, 65, and 75. And what we observe, we can able to reduce. The final the water content was there in a product was around 53 to 54%. Okay, and drying time is vary depend upon the temperature and depend upon the thickness of the slice. And we have find if it is thickness is less, so definitely the drying time is very less, but if thickness is more, drying time is more. Okay, so thickness slice means thicker slice take a more time, which because they contain higher water content. Actually we have studied three different models: the page drying model, diffusion approach drying model, and Middeley drying model. Actually, through this drying model, we able to find out this T, R square, X square, RMSE. R square means differential coefficient. X square means psi square, that we know is statistical term. RMSE means roots means square, and K is the constant. And here we find out, actually we compare three more model, Page and Habis, two-phase differential, and one more is Newton's model. But we found these three models very perfect, because here the criteria that this model is the best is what? Their R square, it should be close to the 1, and their chi square and the RMSE should be very less. So you can see in the data that this three model is, their R square is very close to the 1. So they are better, and their chi square and RMSE, root mean square, is very less. In this particular study, if you want to go further and if you want to study more, so we find out that we can future research possibilities are cost analysis. We can able to explore how ideal drying method affect the cost. Now here our target object is a squash, but we can try with the other other foods like a mulberry and other that is available here in Uzbekistan. We can also can try the different drying methods. Once dried final products, so we can able to test it, and we can able to check the changes in the dried foods. Also, we are going to work how we can better package that particular product, so shelf life will extend. And here it was laboratory test. We have very small quantity of the object, but we can think about the in a big scale how we can dry this. And also we are going to see that how the thing should be eco-friendly, where the less energy consumption, and we can maintain the eco-friendly environment. And also we are going to study what people want in dried food for the better products. So these are our future enhancement that we can, the possible future research. And here you can have the list of the research paper that we refer to study our research. Thank you. Thank you for the listening.
Thank you, sir, for presentation. Sir, my question is, you used three temperature level: 55, 56, 55, 65, and 75. If we will
Yes,
increase the temperature or decrease the temperature, so
absolutely,
what
sir.
will be the effect?
See, if you decrease the temperature, but obvious the drying time will be increased.
Okay.
And if you increase the temperature, drying time will be decreased. But actually,
Okay.
sir, but ultimately, our focus, the final the product after dried, final product is ready, how their natural substance is maintained. Because yeah, in a drying, the reducing the moisture content is important, but along with that, the natural substance should be maintained. That is what our priority. So that's why we selected these three different conditions.
Temperature conditions. Okay, sir. And model is SHS8001.
Actually,
Used.
it is a Russian product. They are given this name to this. If you convert into the English language, it is a cabinet dryer.
Okay, okay,
It's the name of
okay.
the company SH. I cannot able to pronounce that S something, some pronunciation of
Okay.
this. But it is meaning is a cabinet dryer. It is like a, sir, like a 2 feet by 1 feet box,
Okay.
and it is available with the Tashkent State Technical University laboratory. So that's why we use that device.
Okay. Okay. Thank you.
Thank you, sir. Thank you, sir.
All right. Thank you for the presentation, Prof. Abhijit. Yeah. So my question is, you have the three different models and all the conditions for the test. But my simple question is why, how is it that you come to a point to actually choose a squash to use as the I mean the method to be tested rather than other methods?
Actually, yes, sir. Thank you for the question, sir. Actually, this drying model is basically based on some parameters are there. For example, the water content of this product, also the thickness of the products. And already we have studied, for the mulberry fruit before. That time, in my other research, that time we used 6 different models. In that study also we used, in my research, resisted page model is better because of the thickness and the water content level of the mulberry fruit. So we have decided to use this model. And as I told you in my table that, this R square, this value should be the close to the 1. If we use the MATLAB, the tool for that.
Yeah.
So if it is close to, so in this our model, it is close to 1, so that we decided it is a better. And also chi-square and the mean square value should be minimum as compared to the other model.
Yeah. One meaning is a close correlation. Eh?
Yes.
So one of the references is actually a paper of my friend actually from my department, my faculty. Thank you very much. Thank you very much.
Thank you, sir. Thank you for the
Thank you,
and
sir.
thank you to the
Sir, I
MIT
have a
University.
question, sir.
Hi, yes,
I
go
have
ahead.
a question to you, sir. Sir, actually, main purpose is for preserving food, preserving that, preserving squash. Preservation is the main aim.
Preservation, yes. And to increase the shelf life, if you dry it, so we can able to control, we can prevent the bacterial things, particular object. So automatically the shelf life will increase. And it has a high nutrient value, it has some minerals and vitamins, so we can able to utilize for the different purpose.
Okay. So I think a fuzzy logic optimization can be incorporated in this situation.
Yes. Possible.
Yes, sir. Thanks a lot, sir. Thanks a lot
Thank
for
you.
being with us. Yeah.
Thank you very much.
Yes, sir.
Thank you.
So next participant is paper ID 307, Mr. Pavan Kumar. Prediction of diabetes disease of type 1 and type 2 using back propagation neural network.
Yes, ma'am. Yes,
Mr. Pavan Kumar, sir.
I'm here.
Over to you.
My voice is clear.
Yes, sir. Your voice is clear, audible.
Okay.
Yes, sir. Kindly present, sir. Thank you.
Okay. Good morning, all of you. Myself, Mr. Pawan Kumar Singh, and I'm on the behalf of my team members. I'm going to present my topic, that is the prediction of diabetic disease of type 1 and type 2 using back propagation neural network. Thanks to giving the opportunity and for this conference. Okay, ma'am. Now, these are the outlines of my highlights of our presentation: abstract, introduction, literature survey, proposed architecture, result and discussion, future enhancement, and references.
Dr. Pavan sir, sorry to interrupt. Make your presentation with the slideshow presentation, sir.
Yeah, yeah.
Slideshow mode, sir. Yes, thank you.
Okay. That diabetic is a common common worldwide disease among the worldwide. Some common factors contributing are like the wrong eating habit and lifestyle. Large populations from developed and developing countries are suffering from this numerous kind of diabetic disease. Now the medical industries are investing in this research for better prevention and medicines for suffering patients. Every year, diabetic diabetic patients spend millions of dollars from insulin and other measures. Now the researchers are working to find the best solutions how to improve the lifestyle and the disease of diabetic from the patients. Now in this research, I'm applying propose a neural network approach for predicting the diabetic disease. This because this neural network is based on undergoes training for minimizing the errors and improving the improvising the precision for detecting individuals, the person having diabetes or no diabetes. The introduction part of this my research is diabetes is a chronic disease that affect the directly from pancreas. Pancreas is basically generate the insulin in our body. Insulin is the mainly responsible for maintaining the blood glucose level in our body. Many factors like such as excessive weight, physical inactivity, high blood pressure, and abnormal cholesterol level then cause a person get affected by diabetes. It can there are many complications, but increase in urination is one of the most common ones. The symptoms of diabetic like the skin, damaged nervous system, and eyes. If it not treated early, then diabetes can cause the kidney failure and diabetic retinopathy ocular disease. Diabetic retinopathy ocular disease basically the blood vessels in the tissue of our retina they are basically damaged. If this kind of disease is not prevent or not cured in early. Adults are more prone to diabetic up to 17 to 80 years. In the research, 1314 millions of populations were having high blood glucose level and were prone to have diabetic and similar diseases. In the research, 2015-16, 8.6% grows up had showed symptoms of diabetic and related disease. In this decade, diabetic-related patients are increasing around the world. Millions of populations are suffering from high blood glucose level, with 70% of increase rate yearly of diabetic in the world. Now, in our study, we are focused only on diabetic type 1 and diabetic type 2. Actually, there are many types of diabetic, but we are focusing only type 1 and type 2 disease. In type 1 disease, this is a figure of uh, type 1 diabetic disease. This is a healthy structure, but this is a diabetic structure. In the case of diabetic 1, this is the pancreas. Okay, now uh, in this pancreas, the cells are destroyed, and if the cells are destroyed, the insulins are not produced by the body. If the insulin is not produced by the body, this refers to a type 1 diabetic patient. Like in the from two pill, type 1 diabetic cells in the pancreas that make enough insulin are destroyed, so the body is unable to make insulin. If you have diabetic 1, you will need to take insulin every day to survive. While in the case of diabetic 2 patient, the diabetic 2 patient, this is the stomach. We eat the we eat, and the food goes to our stomach, and stomach break our food. And this, if the stomach break the food, and the food convert into the glucose level, and this glucose level enter into the bloodstream. While in the same case, the pancreas are generated the insulin, and if the pancreas are not, the insulins are not basically efficiently used this glucose level, so that the glucose level increases in our body. So this refers to a type 2 diabetic patient. If you stop this diabetic to patient, then you can change your lifestyle like losing weight, eating healthy food, and being active. So in the literature survey, the authors are apply or propose many different kind of machine learning models to predict the person having diabetes disease or not diabetic disease. So the author says that the author collect the data set from UCI machine repository. UCI means the University of California, Irvine machine repository, and working on 15 features of this diabetic data set and utilize and apply their different kind of machine learning models like support vector machine, random forest, and name based. Basically, these are the classification models and predict their accuracies of support vector machine that is 77.73%, and random forest is 75.39%, and name based is 73.48%. Another author collect the data from PIDD. PIDD means PIMA Indian Diabetic Database. Collect the database and apply the three machine learning classification models, that is the name based, SPM, and decision tree, and their predict their accuracies is that is 76.3%, 65.1%, and 73.82% respectively. Other authors use apply the different other different kind of machine learning techniques and and predict their accuracy in corresponding models. Like so, in this our proposed structure, we use a back propagation neural network. So, what is the back propagation? Is probably the most fundamental block of neural network. It is first introduced in 1960, almost 30 years back, by Ruben Hart, Hinton, and Pinel. This algorithm is effectively train a model through a method called chaining. In this simple terms, after each forward pass of network, the back propagation perform a back pass while adjusting their some model parameter like weight and biases. This model is created with the help of Veka tool and created this model in this tool and load the data set of the equation. After train the model along with the learning parameter is a 0.3, momentum is 0.2, and number of epochs is 500. It has been observed that the accuracy of the model is 82.55%, along with the error rate is 0.123. The architecture of the proposed model is this. This is the proposed model architecture. This is the data set. The data set of the type 1, type 2. We process the data and this data loaded in this model. This is model. This is the web application neural network. This layer this is the input layer. This input the attributes into the model. These are the hidden layer, and this is the output layer. This hidden layer consists of 6 into 7 layers. Input the model, and this model basically predict the person having a diabetic or non-diabetic. It means that test positive and test negative. This is the and this is the accuracy. This is the accuracy assessment of this model. The output of this proposed technique is shown in table this one. If the person has been 0, means this is the negative test. If this is the 1, means this is the positive. This is the comparison of model in our proposed model and the existing model. The upper proposed model, the best is the maximum accuracy is compared to the existing models. The future enhancement of our this model is to we will work in future like increase the size of the data set of diabetic and apply the other different machine learning models. And the next is try to predict other some diabetic, like because we have only focus on type 1 and type 2 disease, and in future we have used work on gestational diabetes and maternity or diabetic of the young people. And the third one is apply some other deep learning model to predict diabetic detections. Yes, hello. These are the references of my presentation.
Okay, thank you for the presentation, Pawan Kumarji.
Thank you, sir. Thank you, sir.
In the literature survey, in the first point, you have cited a model named J48. What is the J48?
J48 basically a version of a decision tree. This version of a decision tree. Or this is a model of a classification model. This is a classification.
Okay,
Supervised.
and you
This
use
is
the
a
weak.
supervised machine learning model.
Okay, and you use the
Sorry,
Vika
sir.
tool, and you use the Vika
Yes.
tool, and you can use the another tool for in the place of the Vika tool.
Yeah, sir. Rapid Miner we can also use. And MATLAB also we can use.
Mhm.
So, Rapid Miner and the
Why
other was
you
the MATLAB.
any other if you when available the other tools, why you use the Vika tool? Any advantage and any other thing?
Actually, sir, I am working with this maker tool as actually, sir, we are much more familiar of this tool. So
Okay,
that we can choose that for purpose.
okay. Thank you.
Okay, thank you, Mr. Pawan. It's such
Yeah.
an interesting project, and you have used Weka, and of course, Weka has a number of techniques within it you can use. I suppose all the techniques can be
Yes.
tested in Weka, right? And I
Yeah.
think maybe I'm
Yes.
just trying to suggest here, you might want to try, there's another computational technique that has become rather useful nowadays. Is a rough set theory. Rough set theory, yeah,
Rough set
RST.
theory.
Yes, RSTs.
Uh, yeah.
It's only quite
Okay.
recently that Weka has embedded such a technique as a new technique that I've introduced in Weka. So I suppose maybe you can use that,
Yes.
because this rough set theory is a quite a powerful classification technique. So it might
Okay.
probably give you a good result. I hope it will be
Okay. Thank you.
nice
We
to
will
try.
definitely, sir, we will definitely use this tool and work on this diabetic, like some other diabetic, like gestational diabetes or some new other diabetes on this tool. Just we have reference to me.
I have some friends of my medical faculty, friends of mine. I have introduced them to actually use rough set theory, and they have basically successfully, identified and or rather classified various diseases. So I really hope if you can use that, it would be very much
Okay.
helpful.
Thank you so much. Thank you.
Okay. Thank you very much.
Thank you, Dr. Pawan Kumar, sir. Thank you
Thank
so
you.
much. Yes.
Now,
So
can I
next
leave?
paper.
Can I leave, ma'am?
Actually, if possible, please stay back in the meeting venue, sir,
Okay.
till the end,
Right.
because we will
Okay.
share the feedback form that will
Okay.
be considered for certification process and attendance process.
Okay. Thank you.
So,
Thank you.
thank you, sir. Yes, sir. So next participant is paper ID 362, Mr. Ruchi Goyal, TAVM, a novel video summarization model. Mr. Ruchi Goyal?
Yeah, hi, ma'am. Hi, ma'am.
Yes, ma'am.
Hello, good
Yes, ma'am.
afternoon.
Please, stage is yours, ma'am. Please present.
Ma'am, I am sharing screen.
Yeah.
Ma'am, is my screen visible?
Visible. Visible, ma'am.
Okay. Hello, very good afternoon, sir. Good afternoon, ma'am. Myself, Ruchi Goyal. I am author of this paper, second author. My author one is Dr. Prashant Girdhar Sambarkar. My title is TAVM, a novel video summarization based on text, audio, and video frames. My paper ID is 362. Thanks for giving me the opportunity to present this paper. These are the content, abstract, introduction, existing systems. These are the contents that I will present today. So in today's digital world, the task of video summarization has gained immense importance within the realm of multimedia analysis. A multimedia includes all the elements like text, images, and the audio. Automatic video summary is the process of creating a brief synopsis that summarizes the video by displaying its most useful and relevant elements. Currently, the selection of video segments to be included in the final summary is done in a variety of ways. The task is to analyze video's multimedia data in search of relevance cues that will help in decision making. The proposed TAVM text, audio, and video mode in this paper will provide the video summary using different multimedia elements of text, audio, and images or frames. The proposed TAVM method can be separated into three parts. The proposed process begins with the video processing, where we have used the BIT vision transformer that is employed to recognize objects within the chosen frame. Following that, audio processing comes into the play, which uses speech to text and converters to transcribe the audio content. Finally, the summary builder, which utilizes the GPT-3 based OpenAI, which will generate the summary of the content. And we have done the experiment and analysis on the benchmark dataset summary that demonstrate the effectiveness of the proposed approach. Introduction. Video data is a great asset for information. Video summarization allows for quick browsing by condensing the original video into the brief summary by maintaining only the important information. Potential methods for effectively utilizing video content by identifying and selecting the descriptive frames from the video. The fast expansion of multimedia data transmission over the internet needs the summarization of whole data. A video has a hierarchical structure that records spatial and temporal data as frames, shot, and scene. So it is not possible to watch a whole video all the way, as it would take a lot of time and effort. With the rise of video content as the primary source of data consumption, automation of video summary process has taken center stage, and automatic video summarizing framework is required that generate effective summaries. The existing systems, the text, audio, and vision systems support the actions that are done in various ways. For instance, subtitle files help as a text will helps to understand the video better. The wedding music conveys the festive mood of setting, while the roars of support during the cricket denote a successful run. That's why we have collaborated the text, audio, and the video mode in this paper that will provide the video summary using different multimedia elements as text, audio, and images. Next, these are the different works these are the some of the work which I have included in my PPT, and I have references all the papers in my paper also. So the authors have used LSTM methods to combine the audio visual frame. How ETL uses a structured adaptive network to enhance the LSTM network. Authors have proposed a method is proposed for generating the Soker highlights. Strong audio information obviously improves the summarization of the whole system. Deep learning algorithms are used for the internet trailer of the movie. Sorry. Text and audio modality can help the visual modality comprehend the video structure and content more thoroughly. Text, audio, and visual mode to combine text. So the proposed architecture will combine the audio, text, and video processing that are done separately, and the finally mapping is done. The goal is to provide the most informative video frames using text, audio, and keyframes. This is the proposed architecture in which we have taken the input. From the input video, we have taken the video frames and we have combined the audio and the text. In the audio and the text, pre-processing is done in which stop words are removed, then the score is estimated, and finally test summary is built using OpenAI API GPT-3. For the video frames, we have frames are extracted. After that, sampling is done, redundant frames are removed. Candidate frames are chosen. After that, we have used the BIT vision transformer for the object detection, sparse autoencoder, and K means geometric filter. These are the major steps: input video, video processing, audio processing, summary builder, and the mapping. For the input video, video is taken in MP4 format from the SUMMI benchmark dataset, and audio and video frames were extracted from the video. Input frames were divided into subsets by short segmentation algorithm, and each subset beginning and last frame signify a shift in the content between shots. Frames are extracted and redundant frames were removed, and candidate frames were selected for summarization. Candidate frames are chosen for the collection of frame, and BEIT is used, which is applied to identify objects in the selected frame. Ma'am, just a minute.
Take care, ma'am.
So sorry, ma'am.
It's okay.
Ma'am, actually, due to pollution, weather is not here, so that's why the problem is this.
If you're not able to continue, it's okay, ma'am.
Ma'am, can I show my slides?
Yes, please.
This is the summary builder. Finally, mapping is done.
Ma'am, can you manage or?
Yes, ma'am, I can manage.
So shall we move on to question session?
Yes, ma'am.
Okay.
Thank
Sir,
you,
over
ma'am,
to you,
for
sir.
the presentation. Ma'am, you are using a TAVM technique
Yes,
for
sir.
this video comparison, and other techniques is not suitable for the same process.
Sir, we have used the video for the video summarization. We have used BEIT transformer.
Okay.
Others have used, sir, LSTM and other things also. As BEIT transformer is used nowadays for object detection. In the case of video summarization, it was not used before. So that's why we have tried this for the object detection, for particular object detection.
Okay. Thank you.
Okay, thank you very much.
Okay, thank you, ma'am. Thank you. Sorry, ma'am, for interruption.
Right.
No problem.
Okay, I just have one question here.
Yes, sir. Yes, sir.
What do you mean by video summarization?
Sir, for example, we have the whole video. Right? Like, for example, if you want to go to Agra or any place, you want to see the video of that place, right? It is not possible to watch the complete video of that place. 4-minute video, 5-minute video due to time constraint. So we have a limited time. That's why the video summarization will provide you the small summary or synopsis of that video within the limited time. That's why that will be helpful.
All right. So you're using the summarization in the end by the help of ChatGPT, right?
Sir, I am using the ChatGPT, right?
To come up with a summary of a
Sir,
statement.
I am using the summary of text data that is built using GPT-3 that is based on OpenAI because it needs the modest quantity of text as input because it is not possible to produce huge amount due to accurate and complex machine generated text.
Yeah. Nowadays, there is this latest ChatGPT 4.0. Maybe you can try.
Sir, I will do because basically it was not used before that. So I have tried that 3 to 4 months as the process begins.
Okay, all right. Thank
Using
you
this,
very much.
for the evaluation metrics, I have used the precision recall and F score, and I have get the F score of 0.975 for 200 equals, and higher F measure indicates the greater accuracy.
All right. Thank you very much.
Okay, thank you, sir. Sorry for...
All the best, ma'am.
Thank you, ma'am.
Take
Thank
care.
you so much.
So next participant is paper ID 110. 110 is Shami Samita. Revolutionizing smart healthcare. That is the topic, sir. So, Ms. Shami,
Uh,
please
good
start
morning.
presenting your content. Yes, good.
Yes. Good morning, everyone. I'm Shami Samita,
Presentation
working
is
as an
not visible.
AP.
Yes,
Am I visible?
visible, visible.
Yeah. Good morning, everyone. I'm Shami Samita, working as an AP in Chandigarh University. My paper ID is 110, Revolutionizing Smart Healthcare. So this paper is all about the analysis of cloud of things in the area of medical and healthcare. COT is basically the
Share your PPT.
integration of.
Share your PPT. Sorry to interrupt. Share your PPT. Your PPT is not visible.
Okay, okay, okay. अभी
Share your entire screen, ma'am. Share your entire screen. Afterwards, you select the PPT. Okay. Shami, ma'am, please check in your end. Meanwhile, next participant is paper ID 408. 408. Paper ID in pipeline is 408, Mr. Har Narang. Wheat disease severity assessment. Vinay sir, Dr. Vinay sir, we will call you in the order. So author ID 408. Are you ready?
Yes, ma'am, I'm ready.
Yes, yes, please proceed.
Is my video visible?
Visible, visible, sir. Presenting your content quickly.
Uh,
Yes, visible.
uh, Good afternoon to everyone present over here. My name is Harshad Narang, and I have written this paper with two of my fellow mates, namely Rishabh Saklani and Karan Purohit. And the topic for my research is VDC severity assessment using federated learning CNN for agriculture transformation. So these are the contents which I'm going to explain right now. First is the abstract, then introduction, then the literature survey, then the proposed architecture, the results and discussion, future enhancement, and the references which I have used for conducting this research. Moving on, first is the abstract. So, weed disease detection is very important these days. The research aims to accurately detect and assess various weed diseases, including various diseases such as leaf rust, fusarium, head blight, weed stripe mosaic virus, powdery mildew, and septoria leaf loss. These are some of the commonly found diseases on the wheat plants, and it is very essential for us to prevent this disease as it grows very rapidly. Second comes the federated learning for privacy. I've opted federated learning as this model is used. This model is trained using the federated learning, ensuring data privacy while allowing multiple devices to collaborate on training the machine learning model. The reason for choosing CNN is that it provides a very high accuracy, and I have received an accuracy of 0.85, which is 85%, by demonstrating its ability to predict the severity of weed disease accurately. Farmer and specialist benefits. The technology equips farmers and agriculture specialists with the information needed to take timely measures to prevent disease outbreaks. As it is seen in India that in the rural areas, technology is still not reached to that extent. So this technology can help the farmers to take proper actions at a very early stage of detection of any disease. And also, cooperative learning impact is also a very important perspective of this research. So, second thing is introduction. The global importance of wheat is very important, and we all know that it is one of the most staple meals for most of the Indian states. Wheat is a major source of calories and nutrients globally, but it is susceptible to various pathogens that can harm crops, affecting food availability and cost. Uh, it's a, it is very like important for everyone, but it is also very highly affected by the pathogens. The disease identification severity, deep learning algorithms like CNN and federated learning can accurately identify and assess the severity of wheat diseases, enabling timely responses to prevent their spread. Examples of disease detection: CNN and collaborative learning can distinguish disease like leaf rust, fusarium, head blight, wheat streak, mosaic virus. As I mentioned earlier, also these are some of the common diseases which we find on the wheat leaves. The data collaboration and interdisciplinary learning. Collaborative learning combines data from diverse sources to create more accurate models for disease detection, making it a valuable tool for agricultural research. Challenges and the future prospects. Gathering high quality data and addressing data variability are challenges in using collaborative learning CNN for disease detection, but the potential benefits for agriculture and food security are promising as technology advances. So these are some of the research papers which I have studied before conducting this research. The first one is the QTL mapping for FHB resistance. This identified significant locus related with wheat resistance to Fusarium head blight, which is one of the diseases, shedding light on potential genetic factors contributing to disease resistance. Second is septoria resistance in wheatgrass. Introgressive lines of Thynoprium ponticum were used to assess wheat's resistance to septoria blotch, with promising candidates for developing resistant wheat cultivars identified. Root rot pathogens research involved Biopolaris sorokinanian as the primary cause of root in wheat, with the Fusarium species also implicated. This information can inform disease management strategies. FedProc for federated learning. The novel method of FedProc was introduced for federated learning, demonstrating higher accuracy and cost of efficiency compared to other methods, making it a promising approach for preserving data privacy in collaborative learning. The importance of disease detection. Studies by Vivek Sharma and Peng Jiang emphasize the devastating impact of agriculture diseases and the need for rapid and accurate disease detection with a focus on using machine learning and image processing techniques for early detection. So the proposed architecture is the first is the methodology overview. The proposed studies methodology comprises three main components, which is the data collection and pre-processing and federated learning uses CNN model. And at last, we evaluate a model on various evaluation metrics so that we know how efficiently a model is performing. So moving on to data collection pre-processing, the study collected 8,000 high quality images of wheat plants with 5 different diseases. The data was collected by like two of my friends by visiting various other fields also, and also that my department, my university is having an agriculture department also, through which I gathered some of the high quality images by visiting the field. These images underwent rigorous curation and pre-processing, including scaling, conversion to grayscale, and data augmentation to ensure data consistency and high quality. Federated learning with CNN model. The study employed federated learning using TensorFlow federated to train a CNN model on distributed wheat disease image data while preserving data privacy. The process involved local model training, model aggregation, and communication among partners. The model evaluation, the accuracy of the collaborated learning CNN model was evaluated using a unique data set of 1,000 images. So out of that 8,000, I uniquely identified 1,000 images, which were a mixture of the things which were having disease and which were not having diseases. The evaluation included metrics like accuracy, recall, and F1 score to assess the model's performance. Severity prediction. The trained model predicts the severity level of wheat disease, aiding scientists and farmers in taking appropriate measures to prevent disease spread and enhance agriculture output. Severity levels range from the initial stage to the last stage of the disease development. So this is a kind of a flowchart of my proposed architecture, as I've explained in the previous slide. The first is the data collection pre-processing, then it moves on to the federated learning CNN model, then to the model evaluation and prediction, and then the severity prediction. So the results which I have obtained is that these C1, C2, and C3 are three different slots of images which I have used, which I have referred to as client 1, client 2, and client 3. So this is for C1, that is client 1, the precision comes out to be 91.164, recall as 90.83, F1 score is 90.97, and accuracy comes out to be 0.962. And for the C2 and C3 are mentioned. So the future enhancements are one of the things which I would like to bring to the panel is that I'm working now to integrate these technologies to the drones so that real-time identification can be done. And instead of feeding the data again and again, we can just fly the drone, and the drone can at that moment only identify whether a disease is present at that crop or not. So the advanced disease identification, future enhancements may involve in the integration of advanced computer vision techniques, enabling the model to identify a wider range of weed diseases with higher accuracy. I'm trying to improve my accuracy from 85 to above 90 so that it is more useful for the farmers and the corporates. This can lead to more comprehensive disease assessment, real-time monitoring. Implementing real-time monitoring and feedback mechanisms can help farmers and researchers detect disease as they emerge, allowing for more proactive disease management and minimizing crop losses. Multimodal data integration, the incorporation of diverse data sources such as spectral and environmental data can provide a holistic view of crop health. Combining these resources with image data can enhance disease severity assessment. Mobile and edge computing, deploying federated learning models on mobile and edge devices can bring disease severity assessment to the field, enabling farmers to make immediate decisions and interventions. Automated treatment recommendations, future enhancements can include the development of systems that not only assess disease severity but also suggest specific treatments or interventions, providing actionable insights for disease management. So the thing which I am focusing on currently is that employing this technology in the drones, and as soon as any disease is spotted, it can send a notification onto the mobile or to the control panel of the drone and assess with the possible solutions which a farmer or any person who is assessing the wheat crop can like follow for the prevention of this disease. Thank you.
Thank you for the presentation. In the result, F1 score. What is the F1 score?
The F1 score basically combines the precision and the recall, and it is a evaluation matrix which we use for the predicting the performance of our model which we have used.
Okay, and QTL mapping. Explain.
The QTL mapping is basically used when any image has to be classified on various parameters.
Okay, which type of parameters can you explain?
Sir, if I'm talking about the disease, like which V disease which I'm using, then it can be of like how severe the disease is, what are the patterns being used over there, as image classifying is also used in this thing.
Okay, okay. No, thank you.
Okay, thank you for your presentation, Mr. Harshit. You mentioned that you'll be working on a drone. Has there been any such work that currently going on using drone for identification of the disease?
Sir, I'm researching on that, but like my agriculture department in the university is kind of an interested, and we have developed automated drones in our university only, so that it can be integrated easily and a possible solution can be provided to the like. My main target is to provide this technology to the government so that the areas which are not easily accessible by the farmers, or it takes a very if more time to assess the diseases, can be done in a very shorter span of time.
Okay, thank you very much.
Thank you, Mr. Harshit. Next participant is paper ID 427. Participant name is Dr. Birendra Sharashwat. Data extraction and integration from unstructured electronic health records. Sir, please start your presentation, sir. Paper ID 427. Paper ID 523. Transfer learning based optimized deep learning model to characterize mango leaf.
Yes,
Yes, sir. Yes, sir. Please, sir. Proceed, sir. Yes, sir. Oh my God.
Is my presentation available, ma'am? Is
Visible, sir. Visible, sir.
good afternoon to all the panelists which are available. So I'm here to present my research that is based on transfer learning based optimized deep learning model to characterize mango leaf disease. And these are the authors which are contributed in this paper. These are the content. So first, the abstract is there, introduction, existing system. After that, literature survey and proposed architecture, result discussion and future enhancement and references. So let's start with the abstract of the paper. Actually, we are basically concentrating on mango plant leaf disease. As we know that mango leaf disease poses great economic loss in past few years, and that is required to detect because for a farmer it is really difficult to diagnose the disease because different type of diseases are there, and having same type of symptoms are there for all the diseases. So various technique AI approaches have been used to resolve the issue, but here we are using transfer learning approach to utilize the same issue, and we have used 4,000 images of mango plant disease, leaf disease. We got these images from a well-known repository from the internet. And accuracy of the result after we have find that is 99% accurately we have identified the disease here. Introduction part. As we know that Indian economy is based on agriculture, and uh, mango is also a part of Indian economy, and that will impact due to the plant leaf disease, and that will cause lots of problem when the leaf disease will impact on the plant, mango plant, and that will be several diseases are there, and that will harm the growth and production of the uh, particular plant production and productivity. And so that's why different techniques, AI and deep learning techniques have been used to investigate and diagnose the part of disease here. So in this study, we proposed a technique of deep learning for recognition and evaluating the mango disease in the attempt to support the sustainable agriculture, and desire to preserve the unique characteristics of Magniferia, that is technical name of mango species, and more and stop the loss of identify. And
Dr. Vinay, sir, your screen is not visible right now, sir.
it's
Sorry
shareable,
for the
ma'am.
interruption, sir. Shareable
Wait,
only.
yeah, let me share again.
Yes, sir.
Now it's visible, ma'am.
Not yet, sir. Not visible, sir. So you please share your entire screen and then
Yeah,
select your.
I'm sharing entire screen, ma'am.
Is that okay for the session chairs? Can he continue with this? But he's not able to present. The screen is not visible.
Yeah, it's not showing anything here.
Yes, sir.
Let me do it again, ma'am.
Yes, sir. Yes, sir. Please, sir.
Now it's visible, ma'am.
No, not yet.
No, not yet.
Not yet.
Now, ma'am, it is
visible.
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 Yeah,
Yes, sir.
okay.
Yes, sir. Please proceed, sir. Continue, sir.
So here we try to resolve the problem of identify mango plant leaf disease, and here the healthy and productivity of mango plants are affected by the disease and damages in the leaves, and we try to resolve the problem by a transfer learning approach of deep learning transfer learning approach that will use the transfer learning mechanism, and basically in this mechanism, these are known as pre-trained network as well. The pre-trained network that is already trained by a benchmark data set of huge amount of images that is going to resolve the problem, same type of problem basically. So objective of the pre-trained model is to extract feature from the data set and transfer the weight for the next level, and that weights are basically used to optimize the model basically, and that will enhance the performance and accuracy of the model as well. So here is one image is there that will explain how it will work. It will take image and pretend model will transfer the weight to the next model. And the model performance was measured by accuracy, AUC area for F1 score and recall values. These are the all pre-trained network which we used, which have been used till now in 2018. So we are basically concentrating on ResNet 50 model. So ResNet is a deep residual network, contain almost 50 deep convolution layer, and basically here the input of the image here is 24 into 24, and the output will be the your whatever you want to identify disease here. So kernel size or filter size, we can say we have used over here 7 to 7 and 3 and 2 3 into 2. Fine. So this model we have used, and we have normalized this model with softmax layer, and we have used pre-trained weight over here. So a conventional way to identify the disease is the time consuming and expensive, and basically we need to uh, 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 correctly identify these diseases a complex structure. So we need to invest lots of technology in that case when we try to resolve such type of problems. So here some means author have used this to identify disease by using SVM, and they attain accuracy of 79 and 83%. Now, KNN model is also used for the same, and they attain accuracy of 80%. And SVM classifier is also used to resolve the same problem by using segmentation, and they attain 73 and 95% accuracy over there. So CNN is also used to recognize this problem, and they also handle the same issue with different proposed model. And the availability of the open source platform makes deep learning model to implement and develop such easier. And we presented a pre-trained model or transfer learning model to employ the classification of mallow leaf disease like the powdery millet, anthrax, and red rust. And we basically use a different evaluation parameter to analyze our model. This is purpose methodology over here. So first of all, we have took the data set and we break the data set into training and testing, and then we pre-process the images because the images we need of 24 into 224 size. So we have pre-processed the images, and then we have argumentation approach. So argumentation is basically we use to enhance the image data set, because if you try to use deep learning, you need enhanced data set to basically train your model. So that's why we have used argumentation technique to enhance the data set over there. And later on, we have identify normal or abnormal plant disease. So we have also converted images into RGB format as well. So next step is ResNet model. Basically, we use over there, and that is extensively trained with the image data set, and we use the same for the uh, identify plant leaf disease. And so batch normalization we use over here, and we use droplet layer and rectify linear unit and ReLU activation layer for that, and softmax uh, activation console also we have used. And we have regularized our model with L1 and L2 regularization as well. So in resultants discussion session, actually we have initially took 4,000 images, and that we have enhanced with argumentation approach, and we have performed this experiment by two ways, by sampling and cross model cross sampling. And basically we presented our result over here with 75% of training and testing images, basically 75 and 25. We have divided the complete images, and then we perform the experiment over there. So this is confusion matrix, shows the result over there. And basically the confusion matrix, you can say, will show the misclassified and properly classified data here. That figure 3 shows the confusion matrix, and here is the result for training loss and training accuracy, and validation loss and validation accuracy. That average accuracy is here almost 99%. These are the graphs which we got after experiment. This for training validation, and this is for training loss and validation loss. So future enhancement, we try to implement it on real-time data, and also embed federated learning environment for that, just identify manual lift disease. So till now we have used 4,000 images, and we use pre-trained network to implement the model, and we attain 99% accuracy over there. Actually, we have used different EPO size to implement our approach, but we have used 10 EPOs for training over there to showcase our result. Thank you, sir. These are my references, and thank you.
Thank you for the presentation. In the other methods, support vector machine, can you explain how to work?
Pardon, sir?
Support vector machine, SVM, how to work?
Sir, SVM is a machine learning model. Basically, we use SVM for classify different classes based on the use.
Thank you. Okay.
Yeah, thank you, Dr. Vinay, for the presentation. I must say, sorry that the screen at my end is not actually showing what you were presenting earlier on. So
Okay,
I couldn't get to understand basically what you have described. But I see something that the other presenter has more or less worked on discovering this disease on the mango.
Yeah,
What is the difference between yours and theirs? Because theirs, I think they are working on mold, development of mold. So is it the same or different or what?
Sir, actually, the difference is that we have used pre-trained model over here. Actually, pre-trained model are model that is already trained with large data set, and we apply the same model for the same type of problem. And we have optimized our model with different parameters like epoch value, batch size, and regularization also we have done over here. So that's why the accuracy has improved in this case.
Okay, all right. All right, thank you very much, Dr. Vinay.
Thank you, sir.
Thank you, Vinay sir. So next participant is 1110, Miss Shami. 1110, Miss Shami. Are you here? Shami ma'am, are you here? Yes, ma'am, please proceed, ma'am. Please share your screen. Yes, please proceed. Shami ma'am, we are able to see your screen. You just speak. Start your presentation. You are not audible. Yes. You are not audible still. You are not audible. Not audible, ma'am.
Am I audible?
Yeah, now audible, now audible. Please proceed. Please proceed. Yes, yes.
Good afternoon, everyone. I'm Shami Samita, working as an AP in Chandigarh University. My paper ID is 110, Revolutionizing Smart Healthcare. So this paper is all about the analysis of cloud of things in the area of medical and healthcare. Cloud of things is basically the integration of Internet of Things and cloud computing. Cloud of Things provides high performance cloud-based platform in form of smart healthcare monitoring systems. These systems enable us to monitor the patients remotely and collect their real-time health data. There are tracking variables provided by Cloud of Things to track the patient's health in no time. Then this data can be further processed for the analysis of patient's health and can be stored for the future. Cloud of Things simplifies and streamlines data collection, transmission, computation, storage, and analytics. COT can be connected to IoT powered devices to access information in real time. Cloud of Things can provide virtual consultations as well and smart medication management can give patients reminders to take their drugs on time, which can improve the efficiency of the treatment. There are a number of challenges and limitations for implementing Cloud of Things in healthcare industry. Some of the major challenges are like security and privacy concerns, interoperability, data management and storage, lack of standardization, and so on. There are some regulatory obligations such as HIPAA, that is Health Insurance Portability and Accountability Act, which must be followed by IoT devices to ensure the privacy and security of patients' information. As COT properly work on the network, so reliable and consistent connectivity is always required for this. Higher costs can also be a challenge while implementing COT. Some of the future directions for COT are, we can look at our artificial intelligence and machine learning integration, edge computing for real-time analytics, blockchain for data security and interoperability, continuous advancements in wearable devices, standardization and regulatory harmonization, ethical and social implications. So this paper shows the applications, benefits, challenges of COT in healthcare industry. Looking ahead, COT in healthcare has a bright future. This review paper emphasizes the critical role of COT technologies in smart healthcare. Thank you.
Thank you for the presentation, but slide is not moved, so we cannot.
First slide.
Yeah. Anyway, thanks.
Thank you, sir. Thank you. Thank you so much.
Yeah. The page was static.
Yes, ma'am. Thank you.
Thank you, ma'am.
Thank you. Thank you. Next paper ID is paper ID 523. Dr. Raj Gaurang Tiwari, Transfer Learning Based Optimized Deep Learning Model. Sir, please proceed, sir. Dr. Raj, sir, please proceed, sir.
Ma'am, 523 already presented by me. Dr. Vinay.
Sorry. Now paper ID 427 finished just now.
And 523 I already presented, ma'am.
Hello.
427 is pending.
Sir, ma'am
Yeah.
only presented.
Yes,
Sir, just now who
427
logged
is
in?
present, sir.
Yes, sir. Birendra Singh. So now paper ID 427, right?
Yes, ma'am.
Yes, sir. Please proceed, sir.
Okay. Thank you,
Share
ma'am.
your screen, sir. Yes, sir. So he faced some network issues, sir. So I gave the link under my name. So name will be different. For time being, it is the name. So paper ID 427. Yes. Please proceed, sir.
Yes. Good afternoon, all of you. And over here, my name is Birendra Kumar Saraswat. My paper title is Data Extraction and Integration from Unstructured Electronic Health Records. So these are the contents: abstract, introduction, literature, survey, proposed architecture, results, and discussion, future enhancement. So this is the abstract. Unstructured electronic health record drive much of their cost from the substantial amount of fact that they contain. However, these records are saved in a ramification of format, making extracting and integrating with other fact resources difficult. So, ton of the existing generation of extracting and integrating unstructured fact is confined by scientific understanding, natural language processing technique, and the capability of to discover sequence addition in the records. For instance, that allow you to correctly pick out the pattern in the affected person health records. Natural language processing algorithm must pick out essential medical concept in free text description within the electronic health records. This is the all about introduction. So in information extraction from unstructured electronic health record is a crucial aspect of healthcare delivery. This information provides records about a fraud person, fitness history, permitting practicing to make informed decision regarding his or her treatment by extracting record from EHR healthcare. Say EHR healthcare providing can pick out trend within the patient population that can be used to enhance to affect the person result and care condition. But I think information extraction from electronic health record also can reduce administrative burden uh, on healthcare agencies. So because electronic health record static are already uh, already electrically capture manual information access associated with some statistics and coding is unnecessary. So the record extraction from electronic health record is vital element of the healthcare enterprises. It allows the healthcare provider to look at their uh, patient health fact efficiency and cases. So next is there are some fact of this related to introduction, main contribution of this paper. First one is improve satisfaction of care by reducing mistake and making more information available for evaluation data extraction and integration service can help enhance the first rate care provided by patient. Second one is multiply statistics and get addition to data extraction and integration can result in a higher rate of entry to legacy of electronic fitness report structure, making electronic fact actor accessible across a ramification of healthcare companies. And next one is extra green operation statistic uh, statistic extraction and integration permitted extraction some method and increase accuracy analysis is permitting healthcare company to paint more successfully. Next one is quicker selection making record extraction. In this contribution, we have find record extraction and integration service can help selection maker make quicker decision by making more completion fact available without delay. So next one is progress fact nice This fact extraction and integration can help identify and eliminating inconsistency and erroneous information in the electronic health records. So these are the literature survey. Actually, I have used near about 20, 22 papers, but I explain here some papers. So one of them, however, integrated EHR provided an array of challenges that need to be addressed to maximize ability of this valuable helpful resources. This is uh, this is taken by extracting medical information from free text and unstructured patient generated health data using natural language processes by retained by Aspen Ocean and Rush Home in international and in 2023. Next one is another challenge is overcoming the security and privacy risk of storing and sharing electronic health records. Managing personally affected personal data must be carried out with instance care and accuracy. As usual, use code could lead to breach, identification robbery, and violation. This content has taken uh, from prediction of allergy and disease using DHO based pattern and CNN and mathematical problem in engineering in 2023. So next one is AI algorithm can also be used to improve accuracy, performance of care, and stumble on pattern to development in massive data set, integrate unstructured EHR into medical exercise and an ongoing process that need to be addressed professionally and responsibility. This is taken by from refining electronic medical representation in manifold subspecies BMC one formation in 2022. All these are literature survey are explained, and now this is proposed architecture. So in this block diagram, first step of this process is fact extraction. How to achieve the extraction? It involves locating, isolating, and gaining access to facts from several sources within the electronic health records, and it may be achieved through natural language processing, textual content, mining, web scraping, and other strategy. The second step is information integration. The final step is statistic manipulation. So it involves manipulating the record to facilitate similar evaluation. This diagram is for the proposed model. So this is the basically in this diagram, the first step is involve obtaining fact from extraordinary assets consist of proper producing fitness report structure, local data structure, countrywide health data set database, or outside resources such as newspaper article or other website. As soon as the record have been extracted, it is then depending on the other organizer using decision software program or manually. Second step include integrating the statistics into a unified, safe, commonly in an included patient report. So this process is commonly performed with the help of specialized software that ensure the accuracy and reliability of the fact. Means it is essential to note that using integrated affected person record is essentially for ensuring the continuity of the fact within a healthcare system. So in this, or we can, or it is essentially to note that using integrated affected person record is essentially for ensuring community or healthcare machines. So basically, moreover, integrated patient information also allow for advanced availability of the patient health information to all healthcare vendors concerned with patient care. So data extraction and integration from unstructured electronic health record permitted better coordination of affected person care, advanced control of patient records, and increased availability of health statistics. this is about of real-time discussion. So basically, in this figure, we find out the uh, optimization optimization of what or the ensure each timely processing of the data within the electronic health record and successful integration and evolution of extracted information. In contrast, machine getting to know algorithm may be used to construct a model to correctly extract the uh, applicable data from unstructured electronic health record. So this is already done. And next is this is also another result in our paper. So in this paper, we find the accuracy of the fact extraction technique or the monitor to ensure the information from electronic health record and is correct to reliable, or you can say it could be done through a system of first class manipulation. First class management guarantees that the record extracting are accurate and and that any error of omission are diagnosis of fixed prior integration. And one more, it will be carried out by the way usage of computerized tools which reveal and optimize performance of the information extraction and integration manner. So it will be carried out also with the usage of computerized tools. I have already discussed paragraph also. So last one is a future enhancement. Once the facts are integrated, they can be used for predictive analytics, medical selection, and population health analysis, and other programs. Static extraction and integration is an essential step in adapting EHR as it allows for gathering and evaluating static from more than one system. So this procedure is frequently computerized using software program equipment to ensure accuracy and efficiency. The extract data is commonly stored in a centralized repository and can be used for various medical and function. So we can also, data extraction and integration from unstructured electron health record is retrieving and converging fact from multiple electron health record structures into an unmarried or merit-based layout that may be used for healthcare analysis and choice edit. These are the references. Thank you.
Thank you for the presentation.
Thank you, sir.
What is the full form of the PGHD instruments?
Please, pardon, sir?
PGHD instruments.
PG? Sir, your voice is not clear. Please.
PGHD instruments mentioned in your block diagram and circuit diagram.
Okay. So actually, just wait, sir.
In previous,
Yes, sir.
Previous.
Sir,
8 number slide. 8 number slide. In the center, PGHD instruments. What is the PG?
This is just like I mean, this is just just instrument method, or you can say we can say method just only.
Okay, not any specific type of the
no.
instrument.
Yes, sir. Yeah.
And what is the full form of the PGHD?
Pardon, sir?
Full form of the PGHD.
PGHD, just sir, I have already discussed. This is just just like not particular method, sir. This is not particular method.
Okay, and I think you use any algorithm.
Sir, CNN.
CNN algorithm. Okay, thank you.
But you can say PGHD patient generated health data like this
Yeah, I
you
am
can say
asking the exactly for
yeah sir, but this is not just method.
Yeah.
Okay.
Okay,
So
thank
patient,
you.
yeah, thank you, sir.
Okay, thank you very much for the presentation. I just have one simple question. You have mentioned that at the end of this work, you will be using this information or knowledge for some kind of intervention. So any specific example you can use this for whatever intervention that then you can think of?
Pardon, sir. Please tell me, sir. Repeat, sir.
Yes, you have mentioned in one of the slides that out of this, the knowledge that you gain from this, finally from this project, is to employ a strategy for intervention. You know, so
Sorry,
what
sir,
sort of any
your
specific
voice is
example?
breaking in between. I cannot hear properly.
Okay. Any example you can mention about as far as intervention, you know, that you can use the data for the result of this research for any intervention strategy?
Yes, sir. Sir, something I hear as I told you that in my paper, basically, I use like CNN technique and other thing, EHR, NLP processing, but just like NLP and CNN only.
Okay, all right. Thank you very much.
Okay, thank you, sir.
Thank you.
Thank you. Thank you. We come to the end of the session. We sincerely thank the session chairs for being with us. If you have any feedback, we would like to hear from you, sirs. Any suggestions for improvement to the budding researchers, you can tell them, sir.
I mean, me and Dr. Krishnan.
Yes.
Oh, okay. Well, I'm also a researcher myself. I'm also learning, so it's good that I've gained some good knowledge from all these researchers. So just keep up with the work, you know. I think that's pretty much all. Just keep with the work continuously and finally achieve the target. That's all. Thank you very much.
Thank you, sir. Thank you, sir. Sir, over to Krishan, sir. Dr. Krishan, sir.
Yeah. Thank you. Firstly, I say congratulate to ICTACS 23 team to successfully organize this event and manage all the things and present all the researchers with the good data base in the presentation. And I'm saying congratulate to all the team and the organization. Okay, thank you.
Thank you. Thank you so much, sir.
Thank you.
Our organizing team will get in touch with you, both the session chairs. Thank you for being with us this long.
Thank you.
And your valuable suggestion will give definitely a new insight to all the participants. We wish all the participants to keep in touch for 4th international conference. We will like to hear your research impacts and go in depth into your research. All the best for everybody. Thank you, one and all, from the team of Amity University, Tashkent, and from the Department of Information Technology and Engineering. We thank you all once again. Thank you so much
Thank
for
you very
being with
much.
us.
Thank you for having us. Thank you.
Thank you, sir.
Thank you.
Namaskar.
Okay, thank you very much. Thank you.
Yes, sir.
Can we meet again, Michelle? Right.
Yeah. Yes, sir. Yes, sir.
All right. Bye.
Participants, please, you all are invited to join us in the valedictory session also. So it will be conducted from Indian timing 2:15 to 4:15. Thank you all. Yes.
All right.
I will end the session, sirs. Thank you.
All right. Thank you.